Let us implement the binary search tree. So here to header file, we require the stdio.h as well as the std library because we want the malloc function to allocate the memory. For that we require. So to store the information related to the binary data, we require a node structure. So node structure is type. So we use the typedef struct. So let us welcome back to our data structure journey. Today we are going to implement the binary search tree by using the C language. For that we require the two header file stdio dot input header input output header file. Next one is the standard library header file for the malloc function. Here we require to define a structure type of node which store the information related to the data as well as the pointer to the left child as well as the pointer to the right child. So let's do it. So the node we are declare as a tree here. So first one is the data it's going to store. Second one is the pointer to the left child. So left is a pointer to the left child. Next pointer is a to right child. Then initialize, here what happened, we make a pointer that is the value stored the root. So initialization of the root pointer is a null. Initialize is a null. Then we have to write down how to insert the data into the tree. So here the here the function, better we make the function as a void as well as the function does not take any parameter for simplicity. We have to make like that. So here first we have to create the memory. If the memory allocation is done, then only we can store the data. So we have to write down tree star. So the new node equal to by help of the malloc function, we allocate the memory. Then we have to check whether memory allocation done or not. So new node equal to null means memory allocation is not done. So data insertion cannot possible. Else means memory allocation is done. If the memory allocation is done, then we have to ask the user to enter the information it wants to store inside the tree. So printf. So here BST means binary search tree. Then we have to scanf. Use the scanf to read the value. %d, for example, the variable we store, the value is n. So we have to declare n is a integer data. Integer variable we store the data we want to enter. So once we enter the data and we read the value, then what happened? We have to store the value. So we have to make the tick new node data equal to n. One more thing, that new node, the whatever the node is created, we have to make the left child as well as the right child points to the null. So we make the new node left child equal to new node right child equal to null. So both the pointer of this new node we make as a null value. Then if root equal to null means tree is empty. At that time, if tree is empty means we have to make the newly created node as a root. So tree is empty. If the tree is empty, then what happened? We have to make the newly created node as a root node. Else means we have the root and we have to search proper location where we are going to insert the newly created node. So to get that value, what happened? We need the check whether it's a less than or greater than value of a node. Then only we have to move to the, if it is a less than, then we have to move to the left side. If it is greater than, then we have to move to the right. So what happened? We require two pointers. So first pointer make as a parent equal to null, child we make as a root. As we know that tree structure, we have to it is a recursively tree substructure. So whenever you go to the child means child itself is a parent of its below children. So what happened? We have to make the initialization parent equal to null and we make the child as a root and we have to traverse accordingly to get the proper location of newly created data where we have to insert data. So after that, what happened? We have to check traverse up to how much. So it will be whenever we reach the child as a null. If it is null means after that there is no subtree, so we have to insert at the left child or as a right child. So we have to make the child is not equal to null. So we have to traverse. So here we declare two pointers. So we have to declare two pointer, that is the child as well as the parent. So parent is a pointer, second pointer is a child. Okay. So once we declare, then what happened? We have to, this is the, so initialization of the while loop is starting is the root. Termination is the null pointer. Then what happened? We have to make the parent as a child. So now we have to make the parent as a child. Then we have to check if new node data, if new node data is less than child data, then what happened? We have to move to the left child. So we make the child equal to child left. Else means it is greater than. Then else means what happened? The child data is greater than the new node data is greater than the child node. If it is greater than means we have to move to the right child. So child equal to child right. So up to how much? Still we are not reached the child equal to null. Whenever we write child equal to null means this is the location where we have to insert the data. So whenever we reach the location to insert the data, next question, whether we have to reach the left child or as the right child. If it is less than the that parent's data, then left we have to make the new node as a left child. Otherwise, we have to make the new node as a right child. So here we have to make write down if new node data, if the new node data is less than parent data is less than the parent data, then we have to make the insert into the right child, sorry, left child. Then what happened? We have to make the parent left equal to new node. Now new, because it is a less than the, because this data, the new node data is less than the parent data. So if it is less than the parent data, then what happened? We have to insert into the left child. So we have to insert into else means it is greater than. If it is greater than means we have to make as the right child. So parent right equal to new node. After that, what happened? Our insertion is complete, so we can write down printf insertion complete. It is our choice, whatever we want, we can write down here. It is only output screen, it will be displayed. So now this is the else part is over. Once the else part is over, then what happened? Once else part ending, then this else also we have to make end as well as the insert. So two ending curly brackets we have to write down after that. This is for else part. After memory allocation, this is the else part. This is the end of insert function. So our insert function is completed. Once insert function is completed, in this program, we are not going to create the binary search tree. Also, we are going to print the value. So whenever we print the value, we have to traverse. As we know, traverse of a binary search tree can be possible by three way: pre-order traverse, in-order traverse, as well as the post-order traverse. So here we have to make the traverse by help of a recursive way. So at that time, whenever you go for recursive function, the function should take parameter. So here the function should take the parameter as a root value. So here we have to write down void pre-order. So here we have to pass the root value. So for example, root value we pass as a, here we declare a pointer variable, that is the temp we read a value. Then if temp is not equal to null, we have to traverse until the temp end of the. So then what happened? If it is, then what happened? We have to, it is a pre-order. Pre-order means first we have to print the root value. So we have to write down printf %d. After that, one tab, or you can make the, it is better we make the tab. Then which value? Temp data. It will print the temp data. Then it is a recursive call. So if it is pre-order, which value we have to make the left. Similarly, we can make this one as a, this is right. So this is recursively called. Once it's over, then we have to make the end of if loop. Then if cases not loop, it then is the pre-order. So pre-order of the traverse of the tree is completed. Then what happened? We have to go for in order. So in order also same thing we have to do. Void in order function name. We make the function name as a border. Here also we have to pass the pointer, that is, for example, it is temp. Then if temp not equal to null. In previous video, I have already explained how the recursive function print is going to be done. You can refer this one. Then here in order means first it will go to the left child, then root, then right child. So here we have to printf %d tab. Then we have to write down the temp data. Then after that we have to go to the left child. So how to go to the left subtree? So in order temp left, then we can go further left side. So same thing, this is for the after left subtree, then what happened? We have to go to the right subtree. So here we have to write down the right. So it will go to the right subtree. So this function will call recursively until we did not reach the null value. That's why temp is not equal to null. The loop will be continue. So this is the in order traverse of a binary search tree. Next one is post order. So the function does not return any value, but it is post order. Here also we have to pass the root value initially. So temp. Now, if temp not equal to null, the same thing here we have to repeat, only we have to put the printf statement at last position. Here also the function name is post. So now our all function is completed. Now we have to move to the our main function. So main function means integer main. So main function, for example, we write down in printf. This is for output screen. Implementation of binary search tree. It is our choice. Whatever we want, we can write down in this screen. It is our choice. Here also we can make a menu drive program. Case 1 for the insert, case 2 for the pre-order, case 3 is for the in order, case 4 for the post order. Then case 5 is for the exit point. We can do it. So for that, what happened? We have to go for do while. So do printf one for insert data into pre into binary search tree. Then we can go for second case for the reorder. Then fourth one is post order. Then fifth one is for exit point. Exit. Then we have to scan if whatever choice we enter. For example, we store in form of a choice. So ampersand choice. Choice. So we have to declare the variable integer as a choice. Then we have to make a switch case. Choice. Case 1 is for insert. Case 2 for reorder. Case 3 for in order. Case 4 for the post order. The all traverse we have to call here. Then case 5 is for the exit point. So we have to write down printf. So once case 5 is over, then what happened? Default case we have to write down. Default. So this is end of the switch case. Then this is the end of do case. So do while choice is not equal to 5, then we have to write down the get C. Just we want the output screen should be then return 0 because integer the main function return the integer. Then we have to go for ending call bracket. Now let us see whether any compilation error or not. First let us save. Then we'll okay, last line is semicolon should be present. Okay, here we have to pass the tree. No, not tree. We have to pass the root value. You have to pass the root. For each and every function, we have to pass the root for the traverse of the in order, pre-order, post order. So now let us compile the program. Okay, for get.ch, we require that Conio header file should be included. We are not included the Conio. Now let us run the file. So now, okay. So we have to first, for example, I enter 1 for insert the data. The same value we are enter right now. Let us see that whether we are getting the. So first one is 15. Then again we want to insert. Okay, there should be one tab. Okay, next time we will do it. Let us first go for exit point. I have to rectify here because it's showing the. Okay, insert the data. Please insert the data here. One tab should be present. Otherwise, we are not able to. Main program here. After that, one new line should be created. Now we have to compile and run the program. Yes, right now it's come down. Okay, insert data. So insert the data right now. First data we enter 5. Again we want first we have to create the binary search tree. Then only we can pull to traverse. Third one is the 85. Then 90. Then 70. Then 60. Then 20. This one we are already completed just before. So we are already done the pre-order, post-order and in-order traverse. Let us check whether we are getting the correct answer or not. 2 is for pre-order. So pre-order value is 15, 5, 85, 70, 60, 20, 90. Yes, we got the correct answer. If I go for which one? That is the post order, in order. In order, what I enter? That's the 3 in order. But in order, it's showing the 15, 5. So it is wrong because if you go for in order, data should be in the sorted order. If I go for fourth one, that is the post order, it's showing this one. So means something we did mistake. That's why we are not getting the proper correct answer. Let us go back. There is no compilation error, but there should be some logical error. Let's check it. If we make some here and there left and right, maybe due to that. Pre-order. First we print the root, then left, right. Okay. Then just see in order, the printf should be first, left side should be then in order means left child, then only this value it should be present. Okay. Then post order means this value after that, that's the left, right, this one. If we did such type of mistake now, we will not get the correct answer. Let us compile and run the program once again. The first data we have to enter 15, then we have to enter 5, then we have to enter 85, then we have to enter 90, then we have to enter 70, then we have to enter 60, then we have to enter 20. Then you have to go for pre-order traverse. Pre-order traverse 15, 5, 85, 70, 60, 28, 90. Yes, we got the correct answer. Now we have to go for that is in order traverse. In order traverse, we got the 5, 15, 20, 60. Yes, all data are sorted order. So our in order traverse is correct. Right now, next one is post order. So post order means 5, 20, 60, 70, 90, 85, 15. Yes, we got the correct. So whenever you go for the binary search tree, first we try to draw the small binary search tree and make by in order, pre-order, post-order. Then you try to run the program. Whether you are getting the correct answer or not. Simple one statement, if we may write down here and there, we will got the wrong answer. So, but anyhow, we rectify our compilation error as well as the logical error, and we are already got the correct answer. The code properly. So here what happened? We are include three header file. Then we define a structure of that is tree of a structure node which consists of three information, that is the data, left pointer, right pointer. Data is used to store the information we want to store in the tree. Left is the pointer to store the left child. Right is the pointer points to the right child. Initialization means before tree creation, what is the true root value? Root value is the null value. So we initialize that is the null value. Then, so this is the function we are used for insert the data into tree. Let us understand how it's perform its operation. So for example, what is the initialization? Before that, we initialize that is the what is the root value? Root equal to null value. Now insert. So first time we call the insert and this is the element. This is the element we insert in the tree in the our program execution time. So first value we insert that the 15. So for integer n, so if what happened, n is a variable is declared. Then two pointer, parent and child, two pointer we declared. So first pointer we declared parent is this one, then child. Child is this one. Two pointer we declare. Then we allocate the memory. New node equal to tree malloc. So because we want to store information and we allocate the memory and we define the such a new node. So what for example, this is our new node. New node has three part. This is new node. If new node equal to null, for example, when you allocate that memory allocation is done, that is the 100. So this is the false, it will go to else part. Please enter the data into the binary search tree. So we enter which value? 15 value. So we enter the value is 15. New node data in. So here we store the value of 15. New node left equal to new node right equal to null. So both the pointer we store which value? Null value. So both the pointer we store the value of null. Then if root equal to null means tree is empty. Right now our root is null. If root is null, then what happened? Root equal to new node. What is the new node value? New node value is 100. So what we have to store right now? The root store value of 100. So if it store the value of 100, then what happened? Now root points to the first node. So it points to the first node. It will not exist. So insertion complete means 15 data is inserted. Next one, which 5 we want to insert. So we call the function that is the insert function. At that time, what happened? Again, what happened? It define a variable that is n. Then tree parents, anyhow, tree parents, it's to declare two pointer. Now a memory allocation. For example, we have to allocate the memory. So what happened? We allocate the memory. That memory is, for example, 200 address and it has three parts. If new node equal to null, no, because new node addresses, this is right now our new node. So this is our new node. Previous new node is gone. Right now, this is our new node. Then if printf enter the data into the BST, so what value we have to enter? We have to enter the n value equal to 5. New node data. So what is new node? This one data we store the value of 5. Then new node left equal to new node right equal to null. So now right now we store the value of null here. With the pointer we store the value of null. If root equal to null, root is 100, root is not null. So it will go to the else part. Parent equal to null. So which value we have to store here right now? Parent pointer store the null value. Child equal to root. Which value? That is 100. So we make this one as a point to right now. Parent equal to null, child equal to 100. Why we are doing? Because we want to find out what is the proper location for this pointer. So right now this is child and parent is null. Because this root node does not have any parent child, so that's why we make the parent as a null, child as a root. Then while child is not equal to null, child is right now is 100, so it is true. If it is true, what happened? Body of the while loop will be executed. Now make the parent equal to child. So what is parent right now? It is 100. 100. Then if new node data, what is new node data? 5 is less than the child data. What is the child? Right now child is 15. Yes, it is true. If it is true, then you have to make child equal to child left. Then child equal to child left. So what is the child left? Null. So now we make this one as a null. So if you make this one as a null, then what I mean, it go to the ending curly bracket, it will go to the starting curly bracket. Now child equal not equal to null, no, it is null. So we have to stop here. Now it will go to the next slide. If node means we are already reached the proper position. If when it means in this location means in this node, we have to attach the newly created node. Next question, whether we have to allocate the in the as a left child or as a right child. So if new node data, what is new node data? 5. Parent data, what is parent? Right now parent is 100. 100 means 15. Is less than 15. If it is true, then make parent left. Parent what? 100. What is the value? 100 left. Which value? New node. What is the new node value? New node value is 200. So now this is parent. We have to make this one as a 200. If you make 200 means it will now connect to this cell. Now we make this proper location is over. So this is the way we insert the second node into our tree. So 5 we are inserted, then what is our objective? Objective is to insert the 85. So again we call the insert function. So at that time, what happened? N is a declared, then parent also a pointer is declared, then child also a pointer is declared to point a structure type of group. Then again, we have to allocate the memory. For example, we allocate the memory and memory allocation is done successfully. So for example, this is the address is 300 and this node we make as a new node. This is new node. So new node, we assign the value, then new node equal to null. No, because new node value is right now 300. So it is not null. So it will go to the else part. Printf and please enter the data into the BST. So it will ask us. So what we entered in our program 85. So what is the n value? It is right now 85. New node data equal to n. So what is new node right now? This one data is, what is data we enter? That is the 85. Then new node left equal to new node right equal to null. So here we store the value of null. Here also we store the value of null. After that, we have to go for the proper location. So if root equal to null, root is 100, so it is not null. So it will go to the else part. Parent equal to null. So we have to traverse from root to proper position. That's why we make the parent equal not null means root node does not have any parent. That's why we make as a null. Then child we make as a root node. What is the root node? 100. While child not equal to null. Right now it is 100. So parent equal to child. Right now what is the parent value? 100. If new node data, what is new node data? 85 is less than child data. Child data is 100. 100 means 100 data is 15. No, it is false. If it is false means it will go to else part. Child equal to child, right? What is child? Child is right now 100. 100 equal to 100. Right, 100 right what? Null value right now it is null. If it is null means it will go to ending curly bracket and go to the starting curly bracket. White child is not equal to null. So it is false. If it is false, it will go to the next line. If new node data, what is new node data? This is the new node. This is new node data is 85. Parent data, what is parent? 100. Right now, parent is 100. 100 data is 15. Is less than no. If it is no means else part will be executed. Parent right, what is parent? Parent is 100. What is right? 100 right, that is the null. Store which value? New node. So it will store the new node value. So this is the proper location. We have to insert the data. So it store which value? 300 value. If they store the 300 value, then what happened? Now pointer points to this one. So now what happened? Our insertion is completed or not? So our insertion is completed. So we insert the third element into our binary search tree. For example, we want to insert the one more element, that is 90. So again we call the insert function. Then what happened? This is n, this is parent, this is child pointer. So initialization of the initialization of the node. So for example, we allocate the node. So for example, we allocate the node. For example, address is 500. For example. So if new node equal to null false, it will go to the else part. Please enter the data into the binary search tree. So what value we have to enter? We have to enter the 90. New node data equal to n. New node, what is this? This one is our new node. So new node data means this one we have to store the 90. Left we have to store the null value. Right pointer also store the null value. This line is over. If root equal to null, what is the root? Root is 100 right now. So this also false. Then what happened? Parent equal to null. Why we make? Because we want to proper location. We have to traverse from the root to proper look, searching for the proper location. That's why we make the parent as a null, child as root node. While child is not equal to null. Yes, it is true because child is 100 right now. So parent equal to child. Now what is the parent value? Parent value right now Parent value is 100. If new node data, what is new node data? 90 is less than child data. What is child data? 15. If no, it is false. Then what happens? Child equal to child left, right? Child what? 100. 100. Left pointer store which value? 300. So ending curly bracket, it will go to starting curly bracket child. 300 is not equal to null. Yes, it is true. If it is true, parent equal to child. What is parent? 100. What is child value? 300. So it becomes to 300. If new node data, that is the 90, is less than child data. What is child? 300. Where is the 300? 300 here. Data is 85. 90 is less than 85. No. Then it will go to child equal to child right. Child is 300. Child right equal to right now. Null. It will go to ending curly bracket or starting curly bracket. Child is not equal to null. It is false right now. False means we right now we reach in proper location. Means this node we have to insert the newly created node. Next thing, whether left child or right child as we have to do. So we have to go for new node data is 90. Parent data. What is parent? 300. 300 data is 85. So if it is a sorry, new node data is equal to it is 85. Yes. If it is true, no, it is not true. So it will go to the else part. Parent right. What is parent? Parent right now 300. 300 right is this position. This position is 300 right. Store which value? 500 value. So we have to store here 500. So if we make a 500, now what happened? It becomes to the right child. So we insert the 90 data into our binary search tree. This is the general way we are inserting the data into our binary search tree. There is another method is also present, that is the recursive method. This is the non-recursive method. Actually, first we have to understand the recursive, non-recursive, then it is easy to understand the recursive method to create the binary search tree. Next value is 70, so void insert. So what happened? Declare n is a palm variable, then parent, then child is a pointer. So if new node equal to before that memory allocation, so we have to allocate the memory, that is the 70 memory. For example, allocate the memory 70 for the data store 70. That is, this is our new node. For example, its address is 700 address. If new node equal to null, no. Else part, please enter the data into BST. Which part value we have to enter? We have to enter right now 70. So we enter the 70. Then new node data store the value of n. This value we store the null. This value also we store the null. So this two line is completed. Then if root equal to null, no. Root is 100. Else parent equal to null. So now we store the parent equal to null. This equal to root. What is the root value? 100. Why we are making this? Because we want to know what is the proper location of the newly created node. While child is not equal to null. Right now, what is child? 100. So while condition is true, if the condition is true, then what happened? Parent we have to make as a child. Then new node data. New node. What is the new node? 70. So new node is the data is 70. Is less than child data. Child is 100. 100 data is 15. No. Then what happened? Child equal to child right. What is child? 100. 100 right is 300. So it becomes to 300. Then it will comes to child is 300 is not equal to none. Yes, it is true. If it is true, parent equal to child. Now parents become 300. New node data 70. 70 is less than the child data. 300 data is 85. If it is true, yes, it is true. If it is true, then what happens? Child equal to child left. What is child? 300. 300 left is null. So it becomes to null. Then it go to the ending curly bracket, child is not equal to null. No, child equal to null. So this condition is false. Then it will go to the next line. So means we are already reached this node. This node we have to insert the data. Next question, whether we have to insert the left child or as a right child. If new node data, what is the new node data? 70. Parent data, what is parent? Parent is 300. 300 data is 85. If it is true, then parent left equal to new node. Means we have to insert into the new node as a left child. So parent means 300. Here parent is 300. So 300 left child means this child we have to store which value? New node value. What is the new node value? New node value is 700. So here we have to store the 700. If we store the 700, then what happened? The connection established to this node. So this is the way we can insert the 70 data into the our binary search tree. So next value we want, that is the 60. So if we want to 60, again we are called the insert function. So this is the n, this is the parent, this is the child. I think we are already know how to insert the data. So 70 means 15, 80. Here what happened? 60. So here it will be inserted. So 60 we stored, here we store the null value. Then we execute this for loop, then we'll reach this location. Now this null store which value? This newly created address, that is, for example, the newly created address node address is 900. You store the 900, that's points to this node. Then last one is 20. So 15, 20 is greater than 15, it will comes to here. 20 is less than 85, so it will come to here. 20, then come, then here, this is the 20 location. So this is the null. This is the null pointer. This is the null pointer. For example, address is 400. So it store which value? 400 value. It store the 400 value. So it store the 400 value. So our insertion is completed. So this is the way binary search tree is created. Hope you are able to understand the concept of insertion in the binary search tree. Binary search tree creation is same as the insertion of the data. So next we have to move to how to here perform the pre-order post-order traverse. So this is our pre-order traverse. So pre-order traverse, here we have print the data in which form? It is in case of a recursive way. So what happened? First, that is the root. Whenever we call the function in the menu drive program main function, at that time we pass which value? Initialize the, we temp make as a which value? 100. So we pass the root. So 100 is not equal to null. Yes, it is true. If it is true, it is a pre-order, means first the root value is be printed. So which value it will print? Print data. So 100 data what? It will print the 15 value. Then then what happened? Pre-order temp, it will call which function? Temp left. So temp left means 100 left, which means it will pass the, right now what happened? 200. So it will call this function 200. Then what happened? 200 not equal to null. Then what happened? Print temp data 200 data. It will print which value? 5 value. Then 200 left equal to null. So it will stop. Then it will go to the which value? Right. So temp right means what is the temp? That is the 100 right. 100 right means this value it will go to. Now here what happened? Whenever it go to this one, this left means 300. So first what happened? 300 data it will print. So it will print which value? 85. Then it will pre-order. It will pass the value that the temp left. 300 left, which value it will pass? That is 700 it will pass. 700 it will pass. It means it will go to 700 not equal to null. Yes. Then what happened? First it will print temp data. 700 data it will print which value? 70. Then it will go to pre-order left. Pre-order left means 700 left. What is the value? 700. left 900, so it will take the 900 right now. So 900, so whenever you pass the 900, 900 is not equal to null, it will print which value? 900 data. What is the 900 data? 60. After that, what happened? Pre-order temp left, 900 left. 900, which one is the 900? 900 left is 400. So it will go to this node. So 400, it will pass the 400. So whenever you pass the 400, then what happened? 400 not equal to null. Yes, it is true. If it is true, then what happened? It print the 400 data. What is the 400 data? 20. It will print the 400 data 20. Then what happened? 400 next equal to null. So it will stop. Then it will go to the right. So what is the right value right now? 300, 300 right which value? 900. So whenever, so 300 right is 500. So 500 means it will take the 500. 500 not equal to null. So what happened? 500 data. What is the 500? This is the 500. So what is the 500 data? 90. So it will print which value? 90. So now what happened? Our pre-order traverse. After that, what happened? 900 next is null. So anyhow, it will stop because there is no data to traverse. So here what happened? Our pre-order traverse is already completed. So this is the way recursive function will be called for the this data. So this is our pre-order traverse. If we want to go for the in order, post order, same the logic we have to follow because it called the recursive way. So next one is in order. In order means what happened? First we have to print the no, we don't have to print. First we have to go to the left, then print the data, then right. Because depend upon the position. In order means the data will print in between the left and right call. So first here similarly, as we know in main function we have to pass which value? Root value. So here which value we pass? We pass which value? We pass the root value. That is the value here we pass the 100. So whenever we pass the 100, if temp is not equal to null. Yes, it is true. If it is true, then what happened? In order left. In order left means which value? 100 left, 200. So now we pass the which value? 200. It will go to the 200. 200 not equal to null. Yes, it is true. If it is true, then what happened? It will go to the temp left. Then we call the function 10 left means 200 left. There is 200 left means null. Right now null. So so means this function will not call, then what happened? Print %d temp data. So what is the data? 200 data is 5. So it will print which value? 5. Then what happened? In order temp left. So once you print, means what happened? Left is already over. Then there is, if we call this function, there is no left, no not, so it print the value. Then what happened? It will go to the which value? This value left is completed. Once left is completed, then what happened? We have to print this one, but for this root 100 left is not completed. So what happened? So again it will print which value? 15 value because 100 left is right now, 100 left is completed. Once the 100 left is completed, then we have to print which value? 15. Then we have to go to the this right part. This is the logic we have to follow. So now we print the 15. After that we go to there. So here what happened? This is our right now temp value. So now we have to move to the which value? Because here temp equal to temp left, so a 300 left, 900, sorry, 700, 700 left, we have to move 200, 900, then here what happened? 900 left is 400. So now 400, there is no left. If there is no left, means what happened? After that, we have to print the 20 value. So here what? After that, we print the 20 value. Once we print the 20 value means this left portion is over. Once the left portion is over, then what happened? Now we have to print which value? 60 value. Then this left also is over for this 700 address. Then what happened? 70 we have to print. Then we print the 70. Then what happened? This left is over. Then we have to print which value? 85. Then we print the 85. So now left is completed. Root is completed, then we have to call the which value? Right value. Right, what happened? There is no left, so right will be print. After that, there is no right. So our in order traverse 5, 15, 20, 60, 70, 80, 90. So also we got in a sorted order. So that's why whatever result we got, it is 100% correct. So how to check whether we are getting our tree construction is 100% correct or not? So always try to make the in order traverse. If you got the answer that is the in order traverse is correct, then you 100% know that our insert data into the tree is 100% correct. This is the shortcut method to know whether we are insert the data is correctly or not. So this is the way we can able to do. So our in order traverse is completed. Next, we have to know how we are printing the data in a post order manner. So this is our tree. We have to perform the post order traverse. So here post order means first we have to go to the left subtree, then right subtree, then only the data. Post means after left, right traverse recursively, then only we print that. This is the logic we have to follow. So what is the temp right now? We have to pass the 100. Whenever we pass 100, it will go to the this child. So this child means this child, it will go to this child. Now 100 next means 200. This is 200. Now 200. 200. There is no left child. There is no right child. Once left, right is over, then what happened? We have to print the data. So we print the data 5. So for 100 left is over. For this, we have to go to the right subtree. So for right subtree, this is the left side. We have to traverse 300 left. Then we have to traverse 300 this one. Then we have to traverse this one. So after that 20, there is no left, there is no right. Then we have to print the 20. Once this node is operation is over, means for 900 left is over, there is no right child. So we have to go for data, that is the 60. So for 700, what happened? Left subtree is over. There is no right subtree. Then we have to print this value, that is 70. For this subtree, left child is completed right now. Then right child is, yes, right child is present. If the right child is present, then what happened? We have to go to the right child. Then for this right child, we have to traverse first left, then right. There is no left, there is no right. Then root we have to print 90. Once this root right is over, means for 300, 300 left is over, right is over. Now we have to print the 85. Because left child, right child, then data will be print. So now for 100 address, left child is over, right subtree is over. Now we have to print the root. So this is the way recursive function is going to be performed for insertion. So not insertion, for the pre-order, post-order traverse, all the traverse is performed in this way. Hope you are able to understand how to create the binary search tree by help of inserting data. And traversing or display we can perform in 3 ways, that is the in order, pre-order, post-order traverse. All the things we are completed and we also got the correct result. Also we understand how the program is executed. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you so much.